Good afternoon. I'm Brian Deming, and this is my partner Stephanie. And we did the experiment 7, the determination of the concentration of a weak acid. In this experiment, the objective is to standardize a solution of NaOH and to use this to determine the concentration of a weak acid using a method of titration, an unknown weak acid. And the solutions we used were KHP, NaOH, and an unknown acid. The materials required for our experiment is a burette used for the titration, a beaker to mix the NaOH and DI water, and finally a flask is used in the final titration.
Okay, how we did this was we used 250 milliliters beaker to mix the NaOH and the DI water for the put in the burette. And then we laid out about 0.3 to 0.4 grams of KHP and put that in a 100 milliliter beaker and put it in a beaker and then mix 100 milliliters of water until it dissolved. And then we put 2 drops of phenolphthalein indicator so it would turn pink when we did the titration. And we filled the burette with NaOH so we could do the titration. And then the sodium hydroxide was slowly added to the flask while gently swirling it so you could get rid of the pink until the titration was completed. So it was stopped when it turned pink while you kept swirling it. And the directions to determine the concentration of an acid was given by our instructor, which was pretty much the same as how we determined the concentration of the other acid. And again, 2 drops of phenolphthalein indicator was added, and 4 titrations were done with the unknown.
Here are the results from our first titration of the sodium hydroxide solution. We have our ionic at the bottom and all of our numbers from our titration. These are steps for calculating the molarity of the standardized base solution. This is our sample calculation for trial number 2, by the way. We took our grams of KHP and divided it by the molar mass of KHP to determine the moles of KHP. And since finding the sodium hydroxide molarity is a 1-to-1 ratio, all you have to do is multiply it by 1 mole of NaOH. And then you take the 1 mole of NaOH and divide it by your volume in liters, and that gives you the molarity of your NaOH. And this was done for all of our trials, and our average and standard deviation were calculated. Our average was calculated by adding up trial 1, 2, and 3. We didn't count our rough because that was just to make sure that everything went well. And we found that our average molarity is 0.851, and we plugged our average into the equation to determine our standard deviation, which is 0.008.
To determine the concentration of our unknown weak acid, we used the balanced chemical equation right here with NaOH, and it just dissolves and goes into water. We took the 16 milliliters, converted it to liters, and so the liters crossed out, and got the given was 0.755 molar of NaOH, and we got the molar of OH. And we took the 1.2 times 10 to the -3rd moles of OH. So the the moles would cross out, so you get moles of H plus. The 1.2 again to get the moles of 0.12 of the unknown acetic gas in solution. For the average and the standard deviation, just to get the average molar of for all 3 trials instead of the rough. And we got our average molarity to be a 1.3, and then this is the standard deviation, just 1.98 times 10 to the negative 4.
And in our discussion, the first question asked about if our sodium, what we were given was our sample was contaminated. If our sample of KHP was contaminated, what would change in the experiment? And if it was contaminated, it would seem like there was more KHP because the molarity would be higher due to the smaller measurements of grams, which would affect the concentration and the determination of the unknown acid concentration. The concentration of the acid would be higher because of the higher molarity of KHP. That's back. Our second question was, why do we use KHP to standardize the sodium hydroxide solution? And it was because KHP does not absorb water from the atmosphere where NaOH did. And even if the NaOH was measured carefully, it's still going to absorb water from the atmosphere. And the measurement would make the concentration inaccurate because of the change in mass from the time you measured it to the time you actually used it in your experiment.
And to determine the concentration of hydrochloric acid, we used the Donald's chemical equation, and this was given to us in the problem. And then we used the periodic table to find the grams of Na2CO3, and then grams cross out, and you get the moles. They gave that to us, and then to cross out, you then use the chemical equation up here to get the moles of HCl. And 1.112 moles of HCl. And then those are our references.